Hello, everyone. My name is Dylan Lusk, and I am a general forecaster at the Peachtree City, Atlanta office. Today, I'll be talking to you about Digital Aviation Services and how to populate aviation grids within ForecastBuilder. We'll open with a few quick reminders of why we have transitioned to Digital Aviation Services, or DAS, in the National Weather Service. DAS allows us to provide better DSS to our aviation partners in several ways. First, through the creation of spatial aviation grids, which allow for the expansion of our aviation services beyond just single point-based TAF sites. Doing this has created two new public grids that we forecast and publish, ceiling and visibility. In essence, we are no longer creating point-and-click TAFs, but grids that can be used anywhere beyond just the TAF sites themselves for our aviation partners. Second, DAS seeks to create more consistency between the TAF and the public forecast. Traditionally, TAFs has not always been done alongside the public forecast, and in some cases this can lead to discrepancies between the two. Many aviation partners had noted this, and would sometimes question which forecast they should be using. By creating formatters in a forecast process that is based in our grids, DAS ensures that the two are always aligned so that we can send a clear, consistent message to our aviation partners. Last, DAS creates consistency in the TAF process between WFOs. There are numerous advantages to this. For example, forecasters who back up another office or transfer to another office will be instantly familiar with the process of TAF creation and can instead focus on learning other things, such as the forecast challenges of that region, rather than the technical aspects of different GFE tools, etc. Having a similar creation process also helps create consistency between WFOs for our partners, which in turn eliminates some of the challenges in communication for entities that span multiple WFOs. This can also drive spatial consistency in our grids. Much of this motivation should sound familiar, and leads nicely into our next slide, which discusses why we want to incorporate ForecastBuilder into the DAS process. ForecastBuilder aligns well with many of the overarching goals of DAS we just discussed. In DAS, a big point of emphasis is that if we put a lot of work and effort into getting the grids right, the TAFs will quote-unquote write themselves, though certainly not without some editing and oversight on our part as forecasters. ForecastBuilder provides a science-based approach to the grids that is streamlined, structured, and uniform from WFO to WFO. This allows a forecaster to instantly be able to pick up and create needed grids, even if at a different office or backing up another office without the need to learn new tools. For offices still spinning up with ForecastBuilder, many of the tools will look familiar to the ones you likely already use or have modified within GFE. ForecastBuilder will also highlight many of the other public grids during the TAF creation process, including many non-precipitation types that can be impactful to aviation, encouraging the forecaster to update these so that all elements of the public forecast and TAF will be consistent with one another. And finally, the MBM as a starting point, and combining many of the points above, we see that ForecastBuilder provides internal meteorological consistency both in the WFO as well as between WFOs. Needless to say, we see there are many good reasons for incorporating ForecastBuilder into DAS. So now that we have our reasons for using ForecastBuilder with DAS, let's discuss just how you can do that. For those of you who are experienced with ForecastBuilder, you'll find that the process only has a few minor additional steps and checks compared to your normal forecast creation process. The first step is to choose a time range as normal. A 3-hour TAF cycle has been built into ForecastBuilder with a default of a 30-hour TAF forecast. This length is configurable for your site and may be longer based on local needs or agreements with aviation partners. ForecastBuilder will show the next TAF issuance time just below the highlighted time range option. So, for the 0Z TAF above, this option would be available beginning at 21Z through 0Z. After 0Z, that 0Z option would be replaced with the 3Z AMD, and so on and so forth. You can use this, or you can use a highlighted time range if you want to make a smaller edit. The current time range will be shown in the gray box at the top of the ForecastBuilder window at all times. In the next step, we choose which forecast elements or foundation grids we wish to load and edit. With the addition of DAS, the third column will contain all of the foundational aviation grids which are needed for TAF creation. Cloud-based primary, which will aid in our ceiling grid creation, as well as visibility and the low-level wind shear and low-level wind shear height. If you are at a main TAF issuance period, it is highly recommended that you update all of these in order to bring the latest and greatest model information in for your forecasts. Also, strongly consider updating your public grids with these as well if possible. Many of the TAF elements are dependent on aspects of your public elements. For instance, sky will impact ceilings, wind is directly in your TAF, and many of the others will play into your weather or other non-precipitating elements that can be impactful to aviation and influence your TAF. At the very least, be sure to collaborate with any other forecasters who may be working overlapping grids. And also, remember, the formatters, such as the TAF formatter, are only as good as the grids that go into them. The next step will see our base or foundational grids populate and then allow us to analyze and adjust them. The usual principles apply here. Remember to search for those targets of opportunity when making adjustments, especially in the short term where local knowledge of the forecast area and model biases can add value to the forecast. Many of these grids will be publicly available. Remember to focus on more than just the TAF sites because of this. Our aviation partners, especially those at the FAA and our colleagues at the CWSUs, absolutely will look at these grids beyond just the TAF sites and potentially make decisions based on them. They may even compare them against the TAF. Last, we'll emphasize again that if you put a lot of effort into these grids up front, you'll have to put less work into the formatter produced TAFs. This is a common theme within ForecastBuilder. Putting effort into your foundational grids will pay dividends later. Our next step will be the integrity checks, which include a few additional checks within our aviation grids before moving into the precept type step. There is nothing changed here for aviation. See other training for more detailed information on the precept type step used to initialize your weather types. Remember that your weather types will have a large impact on your TAF formatter, including the potential generation of things like tempos and prop 30s. So don't gloss over this. The next step is the non-precipitation probability of type step, which is definitely a mouthful, and will provide numerous tools to generate pot grids for non-precipitating weather. Please take a moment here to consider if any of these grids may be needed. Many of them are impactful to aviation and will not be in your formatters without considering them here. Several important ones to note are pot fog from visibility, which is a great way to align your visibility grids with your weather grids for fog creation, as well as the similar pot haze and pot smoke from visibility, which will also align with weather grids from those. Please note, and this will be repeated several times throughout the rest of this presentation, that if you do not create any obstructions such as fog or haze or anything like that for your grids, and you do not have at least likely pops, your visibility will be raised in the finalized step to 7. This is a common gotcha for many forecasters that are using ForecastBuilder to generate aviation grids. And like I said before, we will go over it several times and kind of show you a little bit more in detail exactly what that entails. But be warned. The next step will roll through the finalization of various grids before the final publishing step. For aviation, this will create your ceiling grids and finalize the others. A preview ceiling button is available to see what the ceiling grids produced will look like before finalizing them, just in case you would like to make any final edits. Once finalized, you will come to the publish step. As you are creating a TAF, ensure that the aviation button is checked so that these grids will also be published during the publish step. It should be pre-checked because aviation foundation grids were modified, but it's always best to double check that it has been. The TAF formatter will only use the latest published grids for TAF creation, so remember that just saving them is not enough. They must be published. There are some important checks that will take place during the finalize step that we'll detail in the next few slides. The important takeaway is that if some aspects of your grids do not match, they will be changed to do so. As mentioned previously, a really big place this can happen in aviation is your visibility versus your weather grids, where you may have low visibilities but haven't added any obstructions such as fog. We'll detail this a bit more here in these next few slides. When running Aviation Finalize, ForecastBuilder will make several checks across your aviation grids to ensure consistency across the forecast. The first is a familiar one for most. Ceiling grids will only be created where your sky grids are greater than 57 per the definition of what constitutes a ceiling. Anything less than this threshold will be set to the usual negative 30,000. Cloud-based primary will have several checks performed against POPs, where given certain POP thresholds within the table to the right, cloud-based primary will be set to lower values. Generally speaking, the higher your POP value, the lower that it will change your cloud-based primary to a certain threshold. Last will be a check of anything set less than 1, i.e. very low values of cloud-based primary. If sky cover isn't overcast and or visibility isn't less than 7, the cloud-based primary will be set back to 1 in these situations. The final check is a big one, and as I've emphasized previously, is a common mistake that will cause your visibility grids you work so very hard on to be largely reset if you aren't careful. Visibility is going to be checked against your pot grids, such as pot fog / freezing fog and several others like haze, etc. The initial checks listed in the table show how visibility, and in one case sky, will be checked and changed based on what is in your pot grids. Feel free to pause here and take a close look at how your grids may change for these various pot grids. However, also remember that if you do not create any grids that are considered an obstruction, when the check finishes, it will move anything with a visibility that is set to less than 7 without an obstruction to a value of 7. The exception to this is when you have pops in the grid, as the default settings of ForecastBuilder will allow you to keep lower visibility where pops are likely or higher. And with all that, once you have published, you are done, at least with your grids. Don't forget to run that TAF formatter and actually get those TAFs out. And with that, you've learned how to use ForecastBuilder to build TAFs within DAS. Thanks so much for listening. If you have any questions or would like to provide feedback on this presentation, or just about anything ForecastBuilder related in general, see the ForecastBuilder VLab page linked above or reach out to the email address provided here. Have a great day, everyone.